Hi guys, this is going to be a comparison of two different FM transmitters. They're both Chinese transmitters. One of them is 7 watts, that's this one, and this one is 35 watts. One of them has a pretty good signal quality, almost as good as a professional. That's this one. This one, the quality is extremely poor, one of the worst I've ever seen. So you can find these on eBay. They're called 30-watt PLL stereo FM transmitter, and you'll see a version of it that looks like this, but the board is blue. It's the same exact thing. You probably want to stay away from them. They're pretty bad. I'm going to show it on the spectrum analyzer, and then I'm going to show it on the bird meter as well, so you can see the actual power output. And I'm going to do the same with that one. And also, just as an addition, these transmitters, I don't own one, but I know they use a BH chip, so they're probably as bad. So I would stay away from these as well as this kit. It also uses a single chip. Like if you, I don't know, you can't see it in this image, but there's one chip on the board that generates the stereo and the PLL and VCO and everything. So these you want to stay away from. But if you're looking for a pretty decent Chinese transmitter, this one is probably the one you want to get. It doesn't really have a name, that's the problem, so you just have to look for a picture on eBay that looks like it. It's called 7-watt PLL, I think FM stereo transmitter, or broadcast transmitter. I think you have to add the broadcast, otherwise it doesn't come up. It's kind of hard to find. Okay, so I'm going to start the comparison now. Okay, so I've powered up the transmitter. I have it set to 87.9. The power output says 35 watts, and the SWR says 1.4, but it's actually about 1.1. This thing is kind of off, I've found. So it reads a little bit higher than it actually is. Over here, I have the bird meter with a 50-watt element in it. I don't know if you can't really see it. This isn't focusing, but it's 50 watts. And up here, you can see it's putting out exactly 35 watts. So it's putting out exactly what it should be. I have it just into a dummy load right now. And it is drawing 6.3 amps at 13.5 volts. So I did a calculation, it's 85 watts. So it's not super efficient, but it's okay. Also, the cooling isn't too great if you have it on its, like, laying on the fan like this. If you want to increase that, you have to tip it over. So, like, if you're using it for a long period of time, you have to run it like that so that the fan actually gets ventilation. So yeah, I think that's it for this part. Now I'm going to show a spectrum. Actually, before I do that, I think I'm going to set the frequency to the top of the band so we can see what kind of power we get there, so you know how broadband it is. So I'm going to change the frequency. Hopefully I can do that through this camera. Okay, here we go. Alright. Well, interestingly, it says the SWR is lower. But over here, we can see we're only getting, let's see, 27 watts, it looks like. Yeah, about 27 watts. So it's rated as a 30-watter, so that's not too bad. It actually puts out 35 at the low end, so not too bad. But you can also, I found if you mess with this coil right here, you can optimize it. Originally it was putting out about 30 watts, and I brought it up to 35 at 87.9, so like it's possible to maybe squish that in and then get more power at this frequency, but I don't want to try that because I've done it a lot and I don't want it to break off. So now I'll show the spectrum. Okay, now I have it hooked up to the spectrum analyzer. I turned it down to about 19 watts. It's not actually 25 like it shows there, because I wanted to make sure that it doesn't cook this thing over here. So here's the spectrum. Yeah, it's pretty bad. If we zoom in, see if I can do this. Okay, I'm going to zoom in. Right now it's 12 dBm at the peak, and we're at 87.9, but it's reading 88 because it's not too accurate. So I'm zooming in. You can see the areas where they didn't filter the MPX very well, or the 19 kilohertz, I think. So it doesn't look quite as bad when you zoom in on it, but it's still pretty bad. If I relocate the pointer to the top, yeah, I'm putting out 12.6 dBm, which I calculated is around 19 watts at the top. So over here, we can see that it's around, if I get it to a better area, it might be easier. Let me see if I can turn it down. Okay, so now we're exactly at 10 dBm. And down here you can see we're 25, or yes, around 25. So we have 10 there, and we have 25 there, so we have 35. So it's negative 35 below carrier, it seems, roughly. If I zoom in, though, it looks a little bit different, and I'm not too familiar with how this machine works, so I don't know how accurate that is. Like, see, when I'm zoomed in like this, it's showing me negative 30 about. So I'm not exactly sure, but let's say it's negative 30. So if it's negative 30 from the carrier, it means that over here, I can do the calculation. So I'm putting out 19. So let me delete this. Figure this out. I don't know if you can see this, but if I'm putting out 35 watts, it means I have 35 milliwatts of stray radiation in those sidebands. Okay, here's the best Chinese transmitter now. And I've tried a lot more than just these two, by the way, like some of these over here. And I know that all the ones with the BH chip are going to be practically the same, so I just kind of ignored those. This one uses a BH chip, but it's a BH1414K, not a BH1415F. The 1414K is a lot better. You can see over here the spectrum is pretty good. We can zoom in. And right now I'm putting out about 150 milliwatts, I think. It actually puts out 7 watts, but it's only 150 because I did some modifications to the inside. I'm working on some project, so it's only putting out 150 milliwatts, and it's going through the attenuator, 30 dBs. But you can see there's no spurious. There's also no harmonics either. You can't detect them. That's the same on the other one. I didn't show that. On the other one, there's no harmonics either. So, but no spurious on this. At least not detectable with this thing. Right now it's giving me a resolution of negative 40. So not very good. If I had a little bit more power, it might help. Maybe I can change the setting here a little bit. Okay. Okay, so at the top, we're at -10, and at the bottom, we're at -80. So that's pretty good. I mean, you can see if I do more of a span in, you can see that the carrier is not super high quality. Like, there's a lot of power here that's being wasted. It should be a lot narrower than that. Like, this is nowhere near like a Radio Master or anything like that. But I mean, in terms of like, you know, I showed the calculation of what actually -30 dBs is, and it's very low, the amount of spurious energy that you're actually getting. So even though this doesn't look very good, you're not losing that much power over here. It's actually not as important as you might think. It is relatively, though. I mean, it's around, let's see, -40, where it starts to kind of spread out too much. But I mean, -40 is pretty ridiculous. That amount of power is very low. So the amount that you're actually wasting in this extra space on either side actually doesn't really matter. I mean, it's not nice aesthetically, but in the real world, it's probably not going to make a difference. So this is probably the best Chinese transmitter you can get. It's still not like a Radio Master or even a TSA transmitter like, have one right here, like this one. You can get this on eBay. This one's really good. I tested it. It's like you can't detect anything. And also these, it's a very narrow carrier, probably still not as good as the Radio Master, but these sidebands here are cut off so much more than it is on this thing. So yeah, that's pretty much the best Chinese transmitter you can get. It looks like this. This is a 7-watt version, and they also make a 15-watt version. It's called the YF-15B, I think. So yeah, like if you want to buy a cheap Chinese transmitter, you probably want to buy one that is either this, that YF thing, or something else that has a BH1414K in it. The worst one, this one, has a KT08035, I think. I have a sample. It uses this thing. What's on this thing right here is actually underneath there. So it uses a single chip design, and it's, I can't read it through the camera, but it is, it's hard to see. KT0803L is what it uses. So that's like the worst chip. If you find a transmitter that has one of those chips, you definitely don't want to use it. But a BH1414K is the best. So that pretty much concludes this video. I'm going to do another video in the future of comparing this BH chip to a PCS electronics transmitter, which are pretty good. And then I might also compare to a Radio Master, maybe a lower power one, if I can afford it. So, yeah guys, thanks for watching. Something I forgot to add about this transmitter, at full power 35 watts, it blocks out stations for about 2 to 3 miles. So having a -30 dB noise floor, or spurious or whatever, is pretty bad for this thing. It blocks out a lot. So this is not something you'd actually want to use in real life at all.